Notice, and this is the typical copyright. Schedule of videos. By now you know this very well. All 33 videos from section 1 have been published on YouTube in their entirety. Section 2, consumer arithmetic, all 12 of those videos. Section 3 sets all 6 of those videos. So 51 videos total thus far, published in their entirety on YouTube from sections 1, 2, and 3. We are now at section 4, measurement, and this is now the 12th of 17 videos. And then after that we will do statistics. I'm not too sure that I can still keep the schedule. Algebra, hopefully by the end of February. And then March 2025, relations, functions, and graphs. April 2025, geometry and trigonometry. And finally, May 2025, vectors and matrices. Please note this disclaimer. This schedule is just a projection which may or may not be fulfilled. It is not a contract with anyone. So right now we are here, 4.10. Those videos have been published in their entirety. These others only partially. Now, as it relates to this objective 10, as I previously pointed out in the last video, I need to divide it into 2 videos. This is now part 2, so it becomes video 12. So this is now video 12. That will become 13, 14, 15, 16, and this now is 17. So we continue with part B of this objective. Calculate surface area of solids, and to be specific, the solids we will be looking at in this video are these: right pyramids, including cones. So let's begin with the triangular pyramid. This is a transparent version of a triangular pyramid. There's a triangle below here, below here. This is a paper model of the same triangular pyramid. And here is the process of putting together that paper model, almost finished. Close up this side to that side, and then bring this face to meet them. Here is a net of the triangular pyramid. This is the triangle at the base, and these are the 3 sides. Now, unlike the prism, the pyramid has only one shaped end, after which it is named. So if you have a triangle below here, it is called a triangular pyramid. If you have a rectangle there, it's a rectangular pyramid, and so on. Secondly, the pyramid has all triangular faces, unlike the prisms where the faces were rectangles. All triangular faces. And thirdly, from the base, the side faces of the pyramid are inclined towards the apex at the top. So example 1, we have a triangular pyramid here. If you know the 3 sides of the triangular base or any other related data, you can easily find the area of the base. That is this area here, whether it's a triangle or a rectangle or whatever. In this case, it's a triangle. From the base, the side faces of the pyramid are inclined towards the apex, which is the point, which is towards here. These side faces, which are triangles themselves, they join at the top here. Now, these are right pyramids, meaning that the perpendicular from the apex will form a right angle with the base. This perpendicular is normally given as the vertical height of the pyramid, this here. Now, this perpendicular height, as I said, is normally given as the vertical height of the pyramid, vertical height. And that makes it complicated. We will get back to this shortly. But if we are given the slanting height of the face, which is the perpendicular height of the triangle, it becomes fairly easy. So if we are given the slanting height, as in the case of this blue line here, finding the surface area of a triangular pyramid is fairly easy because that vertical height, HS, is at 90 degrees to this side here, PR. To this side here, PR. Now we will only deal with triangular pyramids that have equilateral triangles at the base. So this is the question. Calculate the total surface area of a regular right triangular pyramid if its base has sides of 12.0 centimeters and its slanting height is 15.4 centimeters. Now we don't know the vertical height, but we do know the slanting height, which is this. Now let's deal with area of the base first. Half AB sine C. Now since it is an equilateral triangle, then we know that all the sides are equal and the angle is 60 degrees because all the angles are equal too. So half times 12 times sine 60 would give us 62.35 square centimeters. That's the area of the base. Now, the area of one of the slanting triangular sides would be half of the base, and that base is the base of the triangle, which is 12 centimeters times the perpendicular height, and in this case, that is 15.4 centimeters. We substitute that. This would be the area of one of the side triangles. For three of them, you get that. So now we add those two. This is the area of the side triangles. That's the area of the base triangle. We add them, we get this. That is too precise. We are only allowed 3 significant figures, so we need to round off here. And so you get 340. If you leave it like that, it would look like that 4 is our uncertain digit. So we add plus or minus 0.5 to indicate that this is our uncertain digit and that it is here where we are rounding off. Now, if you find this video useful and interesting, please like and share. Like and share. You may also consider subscribing to this channel. Example 2, which is very similar to that one. Calculate the total surface area of a regular right triangular pyramid if its base has sides of 20 centimeters, one significant figure, and its slanting height is 36 centimeters, 2 significant figures. So our answer can only have one significant figure. We don't know the vertical height. We do know, though, the slanting height, which is this here, 36 centimeters. So let's deal with the area of the base first. Half AB sine C. Since it is an equilateral triangle, then C is 60 degrees. And all the sides are equal, so AB will be 20 and 20, and that gives us 173.21 square centimeters. That is for the base. Now let's deal with the side triangles. One of the side triangles would be half of base. Now that is not a triangular base. That's the base of the side triangle, which we are told is 20 centimeters. 20 centimeters, times its vertical height, 36 centimeters. This will give us the area of one of the side triangles. We have 3 of those. So all 3 side triangles would have a total area of 1,080 square centimeters. So if we want the total area, we will add those 2 areas, area of the side, area of the base, and we get 1,253.21 square centimeters. Obviously, we have too many significant figures here. That is too precise. As I said, this 20 here has 1 significant figure. That 36 has 2 significant figures. If you are not told in a question like this how many significant figures to use or how many decimal places to use, then you would have to use the rule that says for multiplication and division, your answer cannot have more significant figures than the factor with the least number of significant figures. So our answer can only have 1 significant figure. We have to round off at that 1, which is to the nearest 1,000. And since you have these 3 zeros here to specify where exactly we are rounding off, we add plus or minus 500 square centimeters, meaning that if you double this 500, that will tell us where the uncertain digit is and where we are